In this section, what we're going to do is we're going to look at some division problems involving fractions. And so this first one might seem a little surprising to you because there's no fractions involved at all. It's just 12 divided by 4. But we're going to look at this to kind of establish something for later on. Now, I'm going to use here the division sort of idea that what we're really asked to do is divide 12 into 4 equal parts. And so to do that, I'm actually just going to draw a picture. I've got my 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's my 12, and I'm going to put those into 4 equal parts. So to do that, I have 3 here, and 3 here, and 3 there, and 3 here. So when I take 12 and I divide it into 4 equal parts, that tells us that that's equal to 3. Now, the reason why I've done this is I want to establish that there's a different way of thinking about this. Instead of thinking about this as 12 divided into 4 equal parts, what we could do is we could ask ourselves the question, what is 1/4 of 12? Okay, 1/4 of 12 is really what we just found, right? We found that 1/4 of 12, or 12 divided by 4, is equal to 3. Well, the word of, as we saw previously, is actually just another way of saying multiply. So what we really are doing is finding 1/4 times 12. Or, if we wanted to use the commutative property, we can write this as 12 times 1/4. And once again, if we just 12, imagine that's over 1. And now we can use our multiplication technique. 12 times 1 is 12, and 1 times 4 is 4. 12 over 4 simplifies to 3. Now, the importance of this is recognizing that in division, a common technique that we use is, instead of dividing by a particular fraction, so for instance, if we had A over B divided by C over D, what we typically do, or one of the techniques we can do, is we multiply by the reciprocal of the second fraction. So what this ends up happening is we say A over B, first fraction stays the same. So here we saw the 12 and the 12. And instead of dividing, we multiply by the reciprocal of C over D, which is D over C. Remember, the reciprocal of a number is just the numerator and the denominator reversed. This sort of is our rule, and I just kind of wanted to show you this little piece to kind of see how that ties together, right? That 12 divided by 4 is the same as asking what is 1/4 of 12, which then becomes 12 times 1/4. So let's actually let's look at a couple of examples here. Now, this example, I put this one here because I want you to see that actually multiplying by the reciprocal is not the only way you can do this, but we'll start with that technique. So over here I've got 10 over 27 divided by -5 over 9. So I'm going to use the reciprocal rule, and I'm going to rewrite this as 10 over 27 times 9 over -5. So notice I just took the numerator and the denominator and I switched them. So now let's use our multiplication rule. 10 times 9 over 27 times -5. And once again, I'm going to start looking for places where I can simplify or cross cancel. So I notice that the 9 and the 27 can both be divided by 9, making that a 1 and that a 3. And likewise, the 10 and 5 can be simplified by a factor of 5. That becomes a 2, and that becomes a -1. So let me just smooth that over. So now what I really have is 2 times 1 over 3 times -1, which then gives us 2 times 1 is 2, and 3 times -1 is -3. So really, this is -2/3. So this is using the whole multiply by the reciprocal idea. But I did say there's another way to do this, and this other way I just want you to be aware of because it is kind of neat. but it only really works or is only useful some of the time. The other thing we can do is notice that really we can just divide 10 divided by -5 over 27 divided by 9. We're just going to work straight across, right? 10 divided by 5, 27 divided by -9. This is just like the multiplication rule, but we're just doing this with division. And look what happens in that case. 10 divided by -5 is -2, and 27 divided by 9 is 3. So sometimes you don't even need to worry about the reciprocal idea. If you know that if your numerators kind of are compatible and your denominators are compatible, there's no need to do the whole reciprocal thing. You can just divide straight across the numerators and divide straight across the denominators. So just a different technique that sometimes works out pretty well. Our third example here is we're going to divide two mixed numbers, or a mixed number by another. So once again, the first thing I'm going to do is I'm going to put these into improper fractions. 5 times 1 is 5, plus 3 is 8. So 8 over 5 divided by 2 1/2 is the same as 5 over 2, negative, and now we're going to move forward. Now, a common mistake that happens here is people will be tempted to want to cross cancel when it still says division here, but that's actually not going to work out very well. Now also notice if I use the other technique, 8 divided by 5, they're not really compatible, and neither is 5 divided by 2. So we're going to use the reciprocal method here. So I'm going to leave 8 over 5 the same, and then times the reciprocal of 5 over 2 is 2 over 5, and the negative sign. Notice that the negative sign, it doesn't matter if it's with the numerator or the denominator. What's really important in this case is that it's negative, so there's one of these happens to be negative. So let's put these together now. 8 times -2 over 5 times 5, and that is equal to, just back up here, -16 over 5 times 5 is 25. And so that is it's already simplified, and we know that because of there's nothing we could cross cancel, and so this is our simplified final answer. So that's just a look at some different ways to think about dividing fractions.